Welcome to the deep dive. Today we're going to break down NestJS. It's the framework that's really taken over the server-side Node.js world by bringing some much-needed structure with TypeScript, OOP, and functional programming.
It absolutely has, and our mission today is pretty straightforward. We're here to give you, whether you're a developer in the trenches or an engineering leader, a solid game plan for 2025.
Oh, no fluff then.
No fluff. We're cutting right to the chase on 4 huge topics: your project architecture, the current state of the ORM wars, scaling up with microservices, and a really critical security vulnerability that actually targets your own machine.
Okay, so we're starting with the foundations, getting the code structure right, then hitting the data layer, moving to distributed systems, and we'll finish with that urgent security warning. Let's get into it. So NestJS gives you this amazing structure out of the box, but I've seen it get messy. In your experience, what are the most common pitfalls developers fall into, even with a great framework like this?
The biggest headaches almost always come down to how dependencies are managed. The number one sin we see, hands down, is creating circular dependencies.
Right, where service A needs service B.
And B turns around and needs A. Exactly. And you're left with this tightly coupled mess where nothing can be tested or, swapped out on its own.
That sounds like an immediate blocker for any kind of scale.
Right.
What about just the day-to-day stuff, like testing?
Testing hygiene is a big one. It's just a huge waste of time when you see teams bootstrapping the entire application just to run one small unit test.
Instead of just testing the one piece they need.
Precisely. Your tests should be fast. And then there's the other classic mistake: ignoring the built-in features of NestJS, people reinventing their own interceptors or pipes instead of just using the powerful tools the framework gives them.
So if a lot of this comes down to bad dependencies and poorly defined modules, how do we fix that from the get-go with the folder structure?
It all starts there. You have to plan it for readability and a clear separation of concerns. The main idea is to pull anything shared or generic out of your specific feature modules.
Okay, so architecturally speaking, what are the absolute must-have folders inside that SRC directory?
You need a dedicated common folder. This is for all your cross-cutting components, things like custom decorators, filters, guards, pipes.
The tools that you're going to use everywhere.
Exactly. They're your universal utilities. Then you absolutely need a config folder for all your environment-specific stuff, API keys, database strings,
So you're not hard-coding secrets.
Please don't. And a utils folder for pure reusable helper functions, things that do calculations or formatting and don't depend on any other part of the app. Once you pull all that out, your actual feature folders in modules become so much cleaner.
That makes sense for cleaning things up. But how do you structure it to really prepare for long-term growth?
For most medium to large projects, the modular structure is the way to go. Separate folders for users, for products, and so on. But if you're building a truly massive, complex application, you have to level up to domain-driven design, DDD.
Okay, that sounds serious. What does DDD actually look like inside a NestJS project?
It's intense, but it enforces maximum isolation. So instead of just a user module, you'd organize the entire user domain into its own layers.
Oh, layers.
Yeah, like an application layer for your use cases, a domain layer for your core business rules and entities, and then an infrastructure layer for things like controllers or how you talk to the database. It's non-negotiable when you have multiple teams in the same giant repo.
All right, moving from clean architecture to the data itself. The ORM choice can make or break a project. For years, TypeORM has been the go-to for NestJS. If I'm already using it, why should I even consider switching?
And that's the critical question, right? TypeORM is mature, it's familiar, but honestly, it's starting to show its age, especially with performance. We're constantly fighting the N+1 query problem.
Where one simple request accidentally triggers dozens of database calls because of lazy loading.
You got it. It's a performance killer. And on top of that, its migrations can be buggy and lead to schema drift, where what your code thinks the database looks like isn't what it actually looks like.
Okay, so it's carrying some legacy weight. That brings us to the one everyone talks about for developer experience, Prisma, the DX darling.
Prisma is fantastic to work with. It's built around a schema-first approach, and it auto-generates a fully typed client. The developer experience is just incredible. The second you go to write a query, TypeScript knows exactly what the result will look like.
That sounds amazing for safety and speed of development. So what's the catch?
Performance, again.
Yeah.
There's an overhead from its Rust query engine. Now, It's faster than TypeORM for sure, but it's still a layer of abstraction that can get in the way when you need to drop down and write some really fine-tuned raw SQL.
Which brings us to the new player that seems to be winning the performance race in 2025, Drizzle, ORM. What makes Drizzle so different?
Drizzle is it's a completely different way of thinking. It's TypeScript first and SQL first, and it's incredibly lightweight because it avoids what's called runtime reflection.
Let's simplify that. What does avoiding runtime reflection actually mean for me as a developer?
It means it's fast, really fast, because it figures everything out ahead of time during the build process. So when your app is running and needs to query the database, Drizzle doesn't have to pause and think about how to translate your code into SQL.
It already knows.
It already has the optimized SQL ready to go, and the result is near raw SQL performance.
So you're getting almost the speed of writing raw SQL, but with full type safety?
Yeah.
That sounds like the dream for a high-traffic backend.
It really is. It works great with modern serverless databases, and its migration tool, DrizzleKit, is super safe. The trade-off is you have to be a bit more comfortable with SQL concepts. There's no lazy loading, so you have to be explicit about your joins.
But for a new project.
For a new NestJS project starting in 2025, where performance is key, Drizzle ORM is the clear winner.
So once we have our performant data layer, we need to think about scaling the application itself. NestJS seems almost built for moving from a monolith to microservices.
It is. Its modular structure is a natural fit for breaking a large application into smaller, specialized services.
But why take on that complexity? Doesn't that just trade one big headache for like 20 smaller configuration headaches?
It definitely introduces new kinds of complexity, you're right. But for large systems, the trade-off is worth it. The single biggest advantage is fault isolation.
Meaning, if one part breaks, the whole ship doesn't sink.
Exactly. If your billing service goes down, your users can still log in because the authentication service is totally separate. You also get technology flexibility. One team could use Node.js, another could decide Python is better for their specific service.
Okay, so we've split the app by function users, orders, payments. How does NestJS actually get them to talk to each other efficiently?
Well, instead of just using standard REST calls between services, which can be slow, NestJS encourages structured transport layers. For internal communication, TCP transport is very common. It's fast and reliable.
Can you give us an analogy for how that works?
Think of it like a dedicated internal post office. Your main application doesn't need to know how the math microservice does its calculations. It just needs its address.
Okay.
It uses something called clientproxyfactory.create to get that connection. That's like getting the mailbox. Then it sends a message with a specific command, like the word sum, along with the numbers.
And the math microservice is just sitting there waiting for any mail labeled sum.
That's it. It uses a @message pattern decorator that's listening for that sum command. It does the math and sends the answer right back through that established connection. It's way more efficient than a full HTTP request response cycle.
But to manage all that at scale, you need more than just the code, right?
Oh, yeah.
What else is required?
Oh, absolutely. You need a whole support system around it. That means enforcing domain-driven design to keep your service boundaries clean, using an API gateway to manage all incoming traffic, having centralized configuration, and, most importantly, investing in amazing monitoring and logging. You can't fly blind.
We have to shift gears here. We've been talking about performance and optimization, but now we need to talk about an urgent security reality, especially in the tools we use every day.
That's right. We're talking about a recent and critical vulnerability tracked as GHSA 85CG CMQ5-QJM7. It affects the @NestJS DevTools integration package.
And what versions are we talking about?
Any version 0.2.0 and below. And this wasn't a minor bug. This was a critical remote code execution vulnerability, an RCE.
Wait, hold on. Are you saying an attacker could run any code they want on my personal development laptop just by getting me to visit a malicious website while my local dev server is running?
That is exactly the risk. The attack chain was essentially a CSRF leading to a sandbox escape. It exploited the trust we all have in our local development environments.
Okay, break that down for us. How does an attack like that even work? How do they get through the front door?
It came down to two major security failures. The first one was that the package had an API endpoint that would take some JSON, and inside that JSON was a code field with JavaScript in it.
Okay.
And it would execute that code inside a notoriously unsafe sandbox function, vm.runInNewContext. The Node.js docs literally tell you this is not a security tool and can be easily escaped.
So an unlocked door. But how could a random website on the internet even knock on that door on my local machine?
That was failure number two. A complete lack of proper origin checking. The server didn't care where the request came from, so an attacker could craft a simple HTML form on their malicious site.
And when I visit it,
It would submit a POST request with a content type of text plain directly to your local server, probably on localhost malt of 8000. That specific content type let it bypass the normal Core S security checks that browsers use.
wow. So it's a chain reaction? An unsafe sandbox combined with a lack of network validation? What is the mandatory fix?
Anyone using this package must upgrade immediately to version 0.2.1 or higher. The fix wasn't small. They replaced the unsafe sandbox, added strict origin validation, and put authentication in place to secure the connection. You know, our whole deep dive today really highlights this constant tension in modern development. On one hand, you have this relentless drive for performance, choosing things like Drizzle or optimizing with microservices.
And on the other,
You have to have this rigorous, almost paranoid attention to security, especially in the very tools we use and trust every single day.
so for you listening to this, the key takeaways are pretty clear. Enforce structure use DDD when things get complex. Prioritize performance Drizzle as our pick for 2025. And never, ever assume the security defaults are safe, especially on your own local machine.
This whole vulnerability worked because it exploited the convenience and the trusting nature of a local dev server.
Which leaves us with a final thought for you to consider. What are the larger implications of a critical flaw like this in a developer tool? What does it say about the trust we put in our tooling and default security settings across the entire software supply chain?